Okay. thinking about this out loud Thinking about this out loud actually might help, right? So let's go through these. Your loss function is a function of. Okay, so let's put it this way. You're basically you're training a neural network. You end up with an inference function. Okay. Then what you do is, as part of the training, what you're actually doing is you're taking that function, you kind of run an input through it, and then you calculate basically the loss function. The loss function is nothing else than a function that tells you how far off are you from your current inference function and the actual value. So the idea is then you tweak. So you have the derivative of this function, right, in order to basically know how to minimize it, right? That's what you use derivatives for. So a derivative tells you what is the rate of change. And so if a derivative is at its minimum, it means that basically you've kind of minimized the difference between, or you've minimized the difference between the target probability distribution and whatever you're building, right? So it just happens so to be that when you have this loss function to calculate the derivative, essentially you just like either do this by hand, right? You apply the mathematical rule of the chain rule, do the derivative, and off you go, or you use some sort of like program to do that. Now, of course, there is going to be things in the shape of a function that can already sort of like be problematic when it comes to calculating the derivative, right? So, and here's one such thing, right? So if we are using, so it just, what seems to be happening here is I have in the forward pass there's a softmax, because at the end of the day you have your logits and then you want to turn them into probabilities. Now the function when you calculate the derivative, obviously the derivative yeah, well, it's the derivative. Wait. Wait a second. Wait a second. I'm doing something really wrong here. Wait. The objective function. Why am I doing these? That's not. No. That's this what I'm doing. It's okay. It's fine. For a second I thought, it doesn't matter. It's fine. That's what you're doing. So we're doing the derivative of these. Obviously, this includes ypred, so this includes your prediction, right? Now your prediction has the softmax function in it, obviously. It just so happens to be that for some reason when I'm calculating these, essentially I just get a flat loss. This means that the gradient values are just too small, right? Why is this happening, and how can we solve this? Why would this happen? Why is this even a problem, right? The softmax function, essentially, what the softmax function will do is transform a bunch of logits into, yeah, exactly. Now, I guess what's happening here is that, but we don't have to look at these. We have to, so what we have to look at is we have to look at the loss function itself, right? The loss function is going to be, it's a sum of, then the log of this stuff times y true. But essentially, because y true is essentially all zeros and 1 1, right? Essentially what's going to happen is the log of, so what does the log of like the log of 1 is essentially 0, and the log of 0 is essentially undefined. Yeah, but it's getting close to, so log of like 0.01. It's a high number, right? So it's kind of like, what this is doing is, of course, telling you that, let's say, first of all, if whatever you have a 0, right? Whatever you have a 0, let's look at this for a second. Whatever you have a 0, if you and then let's say that let's say it's literally just not matching at all, right? You have 0 probabilities somewhere, and then you have a 1, right? Somewhere, so it's going to be 0 times 0 is just going to be this is just not going to add at all. Whatever there's, and then basically whatever there's a 1 and here's a 0 is going to be just zeros, and if it's zeros and zeros, then it's just going to be zeros, right? So essentially if there's just no overlap, that function is kind of 0 in a way. If you have a perfect match, that function is, you've got a 1 here and a 1 here, right? So np log of 1 is 0 though, so we're gonna have a 0. But because then you have, what? That's weird. Yeah, of course. But because you have a lot of zeros that match with zeros anyway, then you're gonna get a very small number, right? So it's gonna be at its minimum. Now, if you have a complete like disconnect, then you're gonna have a complete, overlap, like I said, 0 and 1. So whatever you have a 0, I guess depends on how you want to define that, right? If it tells you, you should kind of, that it should be these, it's like a spike here, and then the other one is a spike there. I guess the multiplication is anyway going to be look, because it's negative, exactly, so it goes up. So for every single thing that is a 0 in here, but it's kind of a 1, it actually adds up. Yeah, okay, I get it, because it's negative and you cancel negative with negative in here, so that's why essentially it penalizes everything that is kind of a 0, and it shouldn't be. Yeah. exactly. So the problem is, okay, now let's think about these, right? I guess the problem is that if both, if you have things that are very sharp, right? If you have things that are very sharp, then it's not going to work out well, right? Because why? Because if the things are very sharp, and it's not the soft, I think it's not the softmax fault in this case. It's just the nature of your data set, right? If your true predictions are like perfect predictions, then on top of that, your log is also very spiky, so to say. There's not going to be, you don't have, how to put it, like the landscape is very flat. Let's try to do this. Let's try to do one thing, okay? Let's try to plot wait a second, the derivative. You're influencing these essentially, right? But if you're, how do I test that? I wanna, so I wanna plot these. For a sample data set where y true where y true is where y true has instances that are very on like, how to say that, on one element with probability 1 and the rest 0, and the same with y pred. I don't know if it's gonna understand what I mean, but my point is, I think that this is just giving you a very flat function. You know what I mean? I think I actually got it. Let me see. If I take this, so what is it doing? So y true, random choice, indices. What are indices here? Choice. What is choice? Choice. One DLA. Okay, just picks one and puts it in one. The same here. Ah, okay. Okay, that's good. Okay, yeah. Yeah, actually it looks good, actually. This looks very good. Hopefully it works right away. But my guess is that this is going to be very flat. Yes, this is going to be very flat. And that's kind of my theory. That's just very flat. What if now do the same? Now give me another version so that the probabilities are more uniformly spread and not concentrated in one element. I think that is the problem, right? Okay, so now it does this. And if my theory is correct, that should give me something that is not flat, actually. I think really that's what's happening. Yeah, I think we got it. I think that's the reason. I think the reason is that I think that's the reason. Yeah, the reason is that for some reason is that whatever we're speeding out of the logits has very spiked probabilities, and then you get a very flat landscape. So it's got nothing to do with the softmax. It's just that. It's just that the data, the predictions we're making, they're too sharp. Interesting. How to make the predictions less sharp? Okay, but I think that sort of makes sense. I just don't know how to validate this, but I think that kind of makes sense in a way. Cool. Let's see.